My name is Lucas Helton with 360 Yield Center. With the introduction of 360 Rain and all the excitement around 360 Rain, we thought it'd be a good time to kind of take a step back and look at some of the products we currently have to offer and talk a little bit about the approach, what our approach has been over the past several years in designing these products, and then kind of walk through what we see as 4 main components of yield and how each one of these products contributes to those components. So first off, when we start looking at designing products, what we really want to do is we want to make sure we can design something that pays for itself in the first year. So when we look specifically at attachment products like a 360 Bandit, Wave, Chain Roll, or Yield Saver, we want to make sure we get a positive ROI in year one. So along with trying to get a positive ROI in year one, we believe that you don't have to necessarily make big changes to your operation in order to have big impacts on yield. So when we're designing products, we want to design products that you can implement the way you farm now and really make those minimal changes to really have those big impacts on yield. So when we start looking at designing products, what we're really looking at is how we can impact the 4 components of yield. And those 4 components of yield that we focus on are population or ear count, girth, which is how many rows around that ear is going to be, length, which is how many kernels from butt to tip we're going to keep, and then the last one would be ear weight or kernel weight. So talking about kernel weight, we're really talking about how many kernels does it take to make 1 bushel of corn. So the standard unit of measurement has always been 90,000 kernels per bushel. But if we can take that number and make it 80,000 or 70,000 or even 60,000, we can grow a lot bigger numbers with the same amount of kernels. So we'll start talking about the first component of yield, which is ear count or population. So when we start looking at population, we want to make sure if we're dropping 36,000, we get 36,000 plants up. We know that planter pass is the most important pass of the year, and we want to make sure we're getting the most out of it. So when we start looking at the things that influence that planter pass, we've got a few different things that can either positively impact or negatively impact that planter pass. The first one is moisture content of the soil. We want to make sure we're not planting into too dry conditions, but we also want to make sure we're not planting into too wet conditions. The next thing would be seed to soil contact, and there's a lot of things that can influence that, one of which is residue, second of which is what kind of conditions we're planting into. So say we're planting a little bit too wet or we've got a little bit too much down pressure, we can actually compact that sidewall and make it more difficult for those closing wheels to do their job. So we've designed some products that we think can have a big impact on that planter pass, and matter of fact, they actually start with a couple of fall products. So a product like 360 Bullet does a really nice job of running through that soil profile and completely resetting that bulk density that we could have changed throughout the fall or the previous growing season. So what Bullet's all about, it's a deep tillage point, it's a ripper point, and what we found in years past was that inline rippers did a really nice job of lifting and fracturing that soil profile. The trouble with inline rippers, if we're doing deep tillage, is as we go into high yield corn environment, there's an awful lot of residue to manage with that tillage pass in the fall. So what we started using instead of inline rippers was disc rippers. And the trouble with disc rippers a lot of times was that those shanks were staggered. So with the shanks being staggered, they don't do as nice of a job working together. And what we oftentimes end up with is we'll end up with ridges between those shanks. So those shanks do a really nice job of breaking that bulk density where they run, but we always leave a hill kind of between where our shanks ran. And that's where Bullet does a nice job of creating a wake throughout that soil profile and really lifting and fracturing that whole entire soil profile instead of just busting out where the shanks ran. That's extremely important for, 1, compaction, so nutrient access to next spring, and 2, moisture content. So as we bust out that bulk density layer, we ensure that that water can infiltrate easily and evenly the next spring. Another one of the fall products that we oftentimes talk about when we start talking about emergence in that planter pass is 360 Chain Roll. So what Chain Roll does is it pierces that stalk every 1.25 inches, but it cuts it in about 7-inch pieces. So a couple reasons for that. We want to pierce that stalk to allow moisture and air and microbials into that pith to get that stalk broken down for the next year's crop. A lot of people view this as a corn-on-corn type of tool, but the reality of it is soybeans use vital nutrients that are tied up in that corn stalk, and if we can't break that down for the following season, we're really hurting ourselves in the long run by not being able to process that residue. At the same time, we want to leave it in long enough pieces to where we don't hurt ourselves the next year on the planter pass. So we look at a 7-inch piece with chain roll versus a confetti style piece with some of the chopping heads that are on the market. And what we find is that confetti style residue is extremely hard to manage the following spring. So as we start looking at a row cleaner and how it can sweep that residue out of the way, a lot of times what we found with a confetti style roll is that the residue is just too small to be able to be grabbed and swept out of the way by the row cleaner. So we're piercing that stalk every 1.25 inches, allowing for that speedy breakdown process, but at the same time we're leaving it in long enough piece to where it can be managed and swept out of the way the following spring by the row cleaners. So when we start looking at the planter pass, we wanted to look at products that we could design that would really influence that seed to soil contact and really focus on getting that plant up out of the ground evenly and making sure as we got later in the season we'd have an even ear height and an even ear size. So when we look at a product like 360 Wave, 360 Wave is really a 2-part product. So it's a closing attachment as well as a starter attachment. So when we look at it from the closing standpoint, what it's doing is it's slicing through that sidewall and it's rolling a wave of moist soil over top of that seed. So that really does 2 things. One, it eliminates all the air pockets that we can traditionally see with a top-down style closing system. So we look at our V-press wheels, we're trying to close that trench from the top down, and that's where we a lot of times get air pockets around that seed, and we don't get that seed to soil, consistent seed to soil contact that we see with Wave. The reason for that is we're rolling that moist soil over that seed, and we're essentially making the job of the closing wheels a lot easier. So when we look at Wave from a starter attachment standpoint, all of you have seen that tube that runs down the back of the Wave. And we're applying starter fertilizer about 3/4 inch away from that seed. The reason for that is we want that starter close enough to where that radical root can sense that band, but far enough away where we don't have to worry about harming that seedling with that hot band of fertilizer. So what this allows us to do is it allows us to put on a little heavier rate, take more advantage of that phosphorus early while not running the risk of burning that seed. So as we continue to talk about starter, we know it's an extremely valuable input, even on years where we don't see a big yield increase. The reason for that is it speeds up the maturity, especially as we start looking at planting beans a little bit earlier, potentially before our corn. We want to make sure we keep that same harvest date that we have in the past, and using starter is another one of those ways to really speed up that process and get us to harvest just a little bit quicker. However, we realize that it's an expensive input. So along with anything, we've got to measure the profitability of that input. So we've got to look at how much value are we getting out of this product versus how much are we paying for this. So we designed a product called 360 Dash that has the ability to save half the cost and get all the value out of that expensive starter fertilizer. What Dash does is instead of applying a continuous band from end row to end row, a lot of times when we're looking at starter that's got a heavy phosphorus component, and the thing about that phosphorus is it's not going to be mobile in that soil. So instead of going from end row to end row, we're putting a shot of starter fertilizer right on top of that seed. So usually we're looking at about a 3-inch band. We've seen success with as small as a 2-inch shot on top of that seed. So when we look at a 36,000 population in a 30-inch row, we've got about 6-inch seed spacing. So if we apply a 3-inch band right over top of that seed, that means we've got 1.5 inches on either side of that seed for that radical root to grow into and really take full advantage of that phosphorus. So instead of wasting that nutrient 3 inches away from that seed, we're putting it in a concentrated band right over top, getting all the value out of it while saving half or even 2/3 of our cost. So as we start talking about this second component of yield, we're talking a lot about girth. So what I mean by girth is how many rows around is that ear going to end up being. So we've all been out checking cornfields, doing ear counts, kernel counts, and we found those that are only about 12 around, and that's pretty frustrating, right? Especially when we can move right down the row and find one that's 18. And when we start looking at products that influence that, what we're really trying to do is we're trying to make them all 18. We want to be as consistent as possible, and that goes back to our emergence, right? So when we talked a little bit about Wave, and we talked about Dash, and putting a starter fertilizer on to get that plant up out of the ground evenly, consistently, and that's really where it starts. But where it leads to from there is that handoff from seed to crown root. So this is where we want to talk a little bit about a product like Bandit that does a really nice job taking care of that handoff and putting a band of nitrogen right next to that root system so it's immediately available when that plant starts to make that transition at the same time that it's deciding how many rows around it's going to be. So when we start talking about girth, we're talking about V5, V6 time frame when that plant is determining that. So if we stress that plant earlier, we don't have the available nutrients to it at that time, that's when we start to see that yellow corn syndrome. So usually it's that middle of June time frame, early June, where we go out and we see a lot of yellow corn. A lot of the reason for that is, one, carbon penalty. Two, it's traditionally an ammonia type of system. The corn roots just haven't reached that nitrogen yet. So when we start looking at Bandit, we're placing that nitrogen 3 inches away from that seed on both sides, about an inch down. So as we get rainfall, that rainfall drives that nitrogen down in the soil profile and it puts it in a band right by that root zone. So we've taken care of emergence with wave and dash. Now we're on to really getting into the vegetative stage of that plant, and we want to make sure that we've got nutrients available to it at that time so that corn never has a bad day. So that third component of yield is length. So when we're talking about length, we're talking about how many kernels are we going to keep from butt to tip. That's determined around that pollination time frame, so that V12 all the way through tassel, essentially. And when we start looking at length, there's a lot of factors that can influence how many kernels we're going to have, how many kernels we're going to keep on that ear. So things like heat stress, lack of nutrients, too much water during pollination, too dry during pollination. There are a lot of factors that can influence how many kernels we're going to keep on that ear. The reality of it is we can't account for all those factors, but what we can do is we can add systems to our program that really help us bulletproof our nitrogen system and make sure that we're doing all the things we can to be as efficient with our nitrogen program and our cropping system as we possibly can. So when we start looking at products like Y-Drop and Soil Scan, we can really do a nice job of measuring what's going on in the field and kind of seeing what the season gives us. So when we look at a product like Soil Scan, it's all about measuring how many nitrates are out there in that soil. So what's available to that plant at that critical growth stage. So we've done a good job with Bandit of making sure we've got enough nitrogen to get us through V10, so essentially get us through the vegetative growth stage, and giving us a little bit of extra time if we do turn up wet and don't get back across that field with our Y-Drop pass as early as we would have liked to. So we want to make sure we've got a base rate down. Then we go out with Soil Scan. So like I mentioned, Soil Scan is a monitoring, it's a measuring device. And the way we use Soil Scan is we go to the same spot in different fields multiple times. So say we go out on June 10th, we've got a measurement of 20 parts per million, we're sitting in pretty good shape. If we go back on to that spot on June 17th, we go every week and we're measuring that same spot, and we've got a measurement of 30 parts per million. That's a good thing. That means we're converting from ammonium to nitrate. That could be a couple different reasons depending on rainfall. Either one, we've got mineralization, or two, we're converting that fertilizer from ammonium form over to the nitrate form. The opposite can also happen. If we go from 20 parts per million to 10 parts per million, then we measure maybe 3-4 days later because we are getting low, and we show that we're at 4 or 5 parts per million, we need to pull that trigger and make that Y-Drop pass. So Soil Scan is all about measuring and seeing what Mother Nature's giving you, seeing how the season's playing out to make sure we're as efficient as possible with our input dollars. We're not applying more nitrogen than we need to, but even worse than that, we want to make sure we're not applying less nitrogen than we need to. Because the reality of it is, on any given year, it may take 150 pounds of N to grow a 200 bushel corn crop, or it may take 220 pounds of N to grow a 200 bushel corn crop. It's all about how we apply that nitrogen and how the season plays out throughout the year. So when we look at Y-Drop, Y-Drop's all about placing the nutrients where the plant needs it, when the plant needs it. So when we start looking at the timing of Y-Drop, we talked a lot about ear length. So we want to make sure we've got that nitrogen available to that plant late enough in the season to where we didn't risk losing that with a heavy rainfall early, but early enough in the season where we don't stress that plant and run out of N. So it's all about applying that nitrogen right at the base of the root system where that plant can immediately take it up, but at the same time it's about waiting long enough to allow ourselves to see what the season has given us. So in a year like 2012, we could have saved half of our nitrogen units by not applying that early and kind of waiting and seeing what the season gave us to see if we needed to either hold back like we would have in 2012, or maybe add a little bit more like we did in a year like 2015 or even 2021 where we did have heavy rainfall early. At this stage in the plant's life, it's a really good time to evaluate yield potential for that specific growing season. So like I mentioned, on a year like 2012, there wasn't anything there. There wasn't any sense in throwing more dollars at a crop that everyone was going to collect the same amount of insurance on. So we've got both extremes of that. We've got a year like 2012 where it was drier. We've got a year like 2021 where in a lot of parts of the world we need to go in and add more in because we have potentially lost some of that we have applied early. So I believe in 2021 we're still in a high yield environment. However, we do need to be out there measuring and monitoring what's happening in the season, what's happening in the field, so we can go out and make those decisions if we need to apply some more in. So the final component of yield, and probably one that not as many people talk about, but from what we've seen over the past several years can be as big a driver as anything else, is kernel weight. So when we start looking at kernel weight, like I mentioned in the intro, what we're really looking at is how many kernels it takes to make 1 bushel of corn. So the standard unit of measurement has always been 90,000 kernels to make 1 bushel of corn. That's essentially the test weight component. So what we're talking about at 360 is taking that number from 90,000 and seeing how low we can get that. So how much sugar can we pack into that kernel? How heavy can we make that kernel? Because if we can take that from 90,000 to 65,000 kernels per bushel, we dramatically increase the number of bushels per acre that we get off of that crop. So we start looking at kernel weight. There's just a few things that influence that, weather being obviously a huge factor. Another one of those factors would be nutrient availability. So we start talking about how much sugar, how much weight can we pack into that kernel. We start looking at that August time frame when that ear is filling, when that kernel's filling. So essentially from pollination to black layer. Typically that point in the season we've already been through a lot throughout the growing season. So we could have got heavy rainfall, we could have turned up dry, but a lot of times that's when we struggle to have that nutrient available for that crop to take up. So with a product like Y-Drop, we've come in a little bit later in season, we've bulletproofed ourselves, we've protected ourselves from some of those early rains, and we know we've got enough of that nutrient available because we went in there and we've measured with soil scan, and we know we have plenty of nitrogen to finish the race. So another factor that influences ear weight is plant health, and plant health is huge, especially on a year like 2021 where we've had a lot of moisture. If you've been out checking fields, we know we've got disease pressure there. We're talking about southern rust coming up into Illinois already. So we've got a bunch of disease pressure on a year, especially a wet year like this. And even on a dry year, we can see it. So we need to focus pretty heavily on plant health later in season as we start talking about trying to influence that kernel weight. So a product like Undercover does a really nice job of completely coating that plant with fungicide and making sure we get the most effective application possible with those expensive input dollars when we start talking about fungicides and insecticides. So when we look at a product like Undercover, what we're really talking about is dropping that down into the canopy and targeting that ear leaf, because we know that our sunlight factory later in season, we'll start talking about toward the end of July, clear through August and September, is really from that ear leaf up. So we want to make sure we protect those plants to the best of our ability, and Undercover does a really nice job by being able to coat both the bottom and the top of that plant to prevent that disease from coming from the bottom up like we typically see in a lot of these diseases later in season. So what protecting those upper leaves does is it allows us to ensure that they can produce photosynthesis and pack as many sugars as possible into that ear and really add to that test weight, that kernel weight at the end of the season. As we think about the whole growing season and everything we've done so far to protect yield, we really want to make sure that we're not sacrificing something when we go ahead to make that harvest pass. So a product like 360 Yield Saver does a really nice job of reducing the amount of header loss that we typically see on an OEM chain. So what Yield Saver is an OEM gathering chain replacement, and what it does is it covers that gap over top of the deck plates. So what that allows us to do is that allows us to cushion that ear against the deck plate. So as that ear gets pulled down by the stalk rolls, instead of hitting something hard, what we're doing is we're hitting something soft in those brushes, and it's eliminating about 85% of that butt shelling that we typically see with an OEM chain. So to kind of wrap up, like I mentioned, I just wanted to kind of give you guys an overview of all the products that we've got all the different things that we can do to influence yield throughout the growing season, because we know that we've got our highest yield potential when that seed's in the bag at the beginning of the season. And as soon as we take it out of the bag and we put it in the planter, we start messing things up. So at 360, we're all about coming up with solutions for some of the problems that we've seen in the past, and doing the little things that we can incrementally do to add small yield increases to our operation, which in turn add up to big numbers at the end of the day, and oftentimes can reduce our input costs as well. So all about increasing productivity and profitability, and making sure we're doing the best job we can to learn year after year and make those small changes to really influence our operations in the long run.